Today, Reece, Marcus, and I will be teaching you about 7 scientific things, including the following: scientific method, lab skills, physical and chemical properties or changes, states of matter, density, change of state, and finally heating and cooling graphs through a number of labs seen in this video.
First, it is important to measure your liquids to be precise. Each liquid is 10 millimeters, and I used a 50 millimeter graduated cylinder because it is more accurate. If this were an experiment, the control would be the graduated cylinders and the measure of the liquids. The independent variable is the order of the liquids that are placed in. And finally, the dependent variable is whether or not the liquids stack, or the result. The reason the red liquid is on the bottom is because it is more dense. It is more dense than the others because it contains salt. When salt is added to water, the salt dissolves in the water and draws the water molecules together and creates a solution. This is called solubility, and it is a physical property. The next liquid is the second most dense because it is cold. When a liquid is cold, all of the particles are closer together and don't move as much. This causes the liquid to be more compact to its certain area of space it takes up. The third most dense liquid is hot. When it is heated up, the particles in the liquid spread apart and move faster due to rising kinetic energy. This is called thermal expansion, and this is also a physical property. Finally, the clear liquid is the least dense of all the liquids. This is on top because the liquid, or vegetable oil, is immiscible of water. What this means is water and vegetable oil cannot mix together. This is a physical property of the two liquids. Before the ice cube is placed into the pan, it is a solid. But once it is placed into the pan, it begins to melt as the temperature rises. Once the temp has reached a certain point, the ice cube has now become a liquid. Now, the temperature is rising in the liquid again, and it is changing its state of matter. The liquid begins to boil and evaporates into a gas. It becomes a gas once the entire substance has reached a certain stage. All of this heating up is causing a rise in kinetic energy, but as the temp does the opposite and decreases, the kinetic energy also decreases. Instead of evaporation, condensation occurs as the gas turns into a liquid. While that is happening, the temp stays constant. Next, the water freezes, turning back into a solid.
I'm going to go ahead and start off my labs by creating a lava lamp. The first thing we need to do is prep. Efficient and precise lab skills comes into play during this lab. I start off by getting the water ready. I use a graduated cylinder to fill to 100 milliliters and fill the beaker. The graduated cylinder is used for a more precise measurement. I continue by obtaining some vegetable oil and pouring on top of the water in the beaker. There is no required amount for this. You will notice the vegetable oil sitting on top of the water. This is due to the lower density of the oil. Any substance with a density less than 1 gram per cubic centimeter will float on water. Water has a density of 1 gram per cubic centimeter. This goes for any other substance as well. This is the case with the vegetable oil, as shown. This particle diagram is shown to represent the densities of water and oil on top. Food coloring is then added for effect, but it does not sink into the water due to its density less than 1 gram per cubic centimeter. I finally pour in the salt. The water then turns green because the food coloring is miscible with the water. When the water is poured in, you see a lot of it going into the water and rising back up. This happens because salt goes in and drags down the oil in food coloring due to salt's density. After the salt dissolves in the water, the oil rises back to the top. The salt dissolving is a physical change known as solubility. The salt at the bottom of the beaker is dissolving, and once it does, you're able to see the oil returning to the top.
Here we have liquid nitrogen. Liquid nitrogen is a liquid, as the name implies. A water balloon was first put into the liquid nitrogen to freeze. Next, balloons filled with air are put into the liquid nitrogen. The air within the balloons gets colder and colder, and the air's density increases. This is caused by thermal expansion. When the air particles get colder, they become closer together. This allows the balloon to deflate. When the balloons are taken out of the liquid nitrogen, they will inflate due to thermal expansion. As the air molecules heat up, the air within will expand, and it will look like the balloons are reinflating. As you can see, the balloons are reinflating due to thermal expansion. Wow, what a sight. Man, isn't that incredible?
Goes down with the pressure goes up and she hits the back of it.
Here's the water balloon as it has been taken out of the liquid nitrogen. Here, my assistant is cutting off the top.
This is an example of game sex volume. As the volume, the same constant of temperature and pressure on the can is going up.
She is having troubles.
You can
Oh,
see, increase it, cold water,
as you can
temperature goes down and so is the pressure.
the outside of the balloon is water. Outside of the balloon is ice, and the inside is water. The freezing of the water is a physical change and not chemical. It would be it's a physical change because you can revert it back into water. Here's a heating and cooling graph. This is a heating and cooling graph. It shows the solid, liquid, and gas states of a substance. As you can see, for a substance to go to a solid, to a liquid, it must melt. Dun dun dun. Anyway, when it goes to a solid, to a liquid, about halfway through, it just goes to this flat part. Okay? This is because all of the solid has to melt before it's considered a liquid. Because right in between it's like half. And then, to go from a liquid to a gas, it's vaporizing. So, all of it has to vaporize before it's considered a gas.
We will be making ice cream in this lab. You will need proper lab skills to measure and deal with the ingredients in this lab. I begin this by pouring a cup of whole milk into a quart bag. I then measure a half teaspoon of vanilla into the bag. All of these measurings you see here are a good demonstration of lab skills. I then get a tablespoon of sugar and add it to the quart bag. 4 cups of ice then need to be put into a gallon bag, which will eventually go around the quart bag. The ice is then followed by 4 tablespoons of rock salt. The rock salt in the ice acts as an even intenser cooling effect. Intense shaking then takes place. Before the shaking, you must make sure to get all of the air out of the bags. I will go ahead and explain what is happening during the shaking. The quart bag before the shaking was liquid, and the gallon bag before the shaking was solid with ice. Throughout the shaking, the quart bag and its contents experienced an exothermic reaction because it absorbed the cold of the ice and released heat into the gallon bag and its contents, creating an endothermic reaction. By the end, the quart bag's contents changed from a liquid to a solid, showing a change of state. The ice showed solid to a liquid, which is also a change of state, known as melting. And then the quart bag turning from liquid to a solid is known as freezing. You'll be able to see this on a heating and cooling graph at the end of this video. The ice and salt show an example of thermal conductivity by allowing the heat of the quart bag to transfer to the ice and melt. During the shaking, you also see melting of the ice, as stated earlier. The changes of state are clear in this lab. Finally, on the graph you are about to see, you will be able to see what is happening during the vigorous shaking process. On this heating and cooling graph, you're able to see the stages and the states of matter and the changes of state. The ones dealt with in this ice cream lab include solid and liquid. The solid, which was the ice, went to a liquid by melting during the thermal conductivity. That is known as melting. That is a change of state. And the liquid, the ice cream, to a solid. That was known as freezing.